This is the second part of my ALU video series. I'm looking at my ALU that I'm making for my 6502 CPU project. And last time I was doing logic functions, which involves things like and or, and I was looking at the results on these LEDs here. So I was putting values into registers and viewing them in binary. But adding, when you add things, you can't view it in binary. It doesn't make any sense, does it? So let's get rid of those. What we need to do is view it in decimal. So I've got something to view it in decimal, which I'm quite pleased with, which I've made sort of my own invention, I think, which is these tiny little screens here. So it's, I don't know what resolution that is. I think it's only a few pixels, like 128 pixels by 32 or something. An 80 tiny processor in there, microprocessor in there. And they plug in here like this. And you can see the value in decimal, which makes it about 1,000,000 times better. Now I was hoping that I'd be able to fit them both in, but I've got a feeling they're going to collide a little bit with each other, so I might have to do some wangling here. Okay, so I've got my ALU board in the center here, the A input register on the left, the B input register, which I've had to crank up a little bit to fit, on the right, and the sum display coming out of the back here, the total, I suppose you could call it. I'm configuring the ALU's instruction here because there's about 32 different things that the ALU can do. I'm putting numbers in on this keyboard here, and I'm simulating my control unit by pressing buttons over here because I haven't got it linked up to the CPU control unit yet. So I think I've configured it for an add with carry instruction. So if we try to put in a number like 2 into A, so publish it 2 onto the bus, store it in the A input, in the A input there, publish 4, should we do, on the B side, on the B input register, so that's 2, add 4, get it to do the sum, and publish the sum to the screen, 6, excellent. So we've done an add with carry, and I've got carry, which is over here, I've got carry turned off. So if we turn carry on and do an add with carry, we should get 7. We do, excellent, we get 7. Could really do with a display here so that I can see the result without having to publish it onto the bus and get it at the back. But I've only got 2 of these screens and 2 of these AT Tinies. It's an AT Tiny 3216, which is the surface mount ones, one of the new ones. It's actually very good. Okay, so that was add with carry. If we turn the carry off, and it's negative going logic, so up is off irritatingly, and we put in a decent kind of amount in there. So let's put in a number like, more interesting than that, so 252 plus 3, 255, right, so 252 plus 3 gets us 255, exactly, with no carry coming out. So the outward carry is this tiny little LED sitting down here. So if we were to have carry coming in, then we would get carry out. The ALU already knows that because it's permanently doing the sums. So 252 plus 3 is 0 with carry coming out. So that's the confusing thing about 8-bit binary arithmetic, or I suppose you could say 8-bit decimal arithmetic. You can only store 255 as a maximum. So 252 plus 3 plus carry is 256, which wraps around to 0 and gives you carry out. So the carry has a weight of 256 effectively. So if we were to put in a number like, let's make a number like 200, shall we? Where's 200 on that? There you go. So 200, we'll put 200 in A, put 200 in B, we'll get rid of the carry, and we'll just add those two together. 200 plus 200, you'd think you'd get 400, but you get 144 and carry, so that's 256 plus 144 is your actual answer. So that's the tricky thing with 8-bit arithmetic, you run out of information. Let's do some sums that are a bit more, that don't wrap out of the end, just to check things are going. 12 as 21 is 33, not bad, so it's all working nicely. Now, the other instruction that I need to do in my ALU is subtract. And they only ever do a subtract with carry, but I think it should be called subtract with borrow, because when you're subtracting, the carry flag kind of works like a borrow flag. So let me see if I can configure that. I think that's off, 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 on, off, actually, is what I think that is. So that's going to be confusing if the very first sum we do is that. So let's put 21, and we will take away 2. So 21 take away 2 is 18. Ah, right. So the reason that this is confusing is because when you're in subtract mode, you use the borrow flag instead of the carry flag, and the borrow flag is the inverse of the carry flag. So you have to put carry on, which is down on my switch because of negative going logic, in order to say, you have to put carry on to mean you want borrow off. That is confusing, isn't it? So 21 minus 2 is 19, and we're getting carry out, which means we're not getting borrow out. So it means no borrow was done. It's making my head hurt. Borrow is just such a confusing concept. In this ALU, borrow is the opposite of carry. So if you've got carry, you haven't got borrow. If you've got borrow, you haven't got carry. Oh, let's try another sum and see if things get any clearer. Let's put that in. That's a nice number. What's that? 31. 31. Well, let's go for something higher then. Let's pick a random number there. 59. Let's take away 59. Let's take away 21. 59 take away 21. We're not putting a borrow in, so we get 38. If we do put a borrow in, we get 37, because borrow effectively takes one more off. So it works the opposite of carry. It's just plain confusing. And if you want to have your brain mangled even more, if we did 21, take away a number that's bigger than 21, like, well, it's not bigger than 21, is it? Let's try again. 75. So 21 take away 75 is 202, because that's the result in signed decimal. So the answer should be minus 56, but minus 56 in signed 8-bit arithmetic is 202. Let's do an even simpler one so we can see what's going on. It is just confusing. So if we say 3 take away 4, in fact, let's take away 4. So 3 take away 4. We haven't got carry going or borrow going in, so the answer should be minus 1. Well, minus 1 I definitely know is 255. Yep, so 255. If we were to take away 5, we'd get minus 2. 25, so we end up with 254. So in 8-bit numbers, to go into negative, you do 256 minus the number. So minus 2 is 256 minus 2, which is 254. So yeah, it's the right answer, but 8-bit arithmetic is plain painful.